Hi everyone, Vladimir is here with our multi-platform game development. In our previous lesson, we have added the effect that is going to be shown when the enemy attacks, but we have not actually added the enemy. So, in this lesson, I'm going to address that and fix that problem. First thing first, let's actually prepare the resources, and I'll show you my desktop. Let me open the tiles that we have been planning on using, and let's just cut any tile that we want. I like the spider. We're just going to use the spider as an enemy at first. Let me select it. And 16 by 16, same size that we usually use. Let's make a new picture. Spider, here it is. Here's our spider, and let me save him to our programming folder, which is dodging hero, and there's this asset folder. I'm saving it as spider. Simple. Spider PNG. Great, so we saved the spider, and now let's actually work on our code. And first things first, the spider is going to be a sprite, like our player, but the enemy sprite. So let's go to our resources and actually declare the sprite, the spider sprite, public sprite enemy. I'm calling it an enemy. And enemy, initialize it the same way as you initialize the player, like the new sprite, which is made from the texture region, except like change the name to spider instead of a player. And after that, let us actually work on the player class, on the enemy class implementation. It will be the same, located in the same package, logic objects, but apart from enemy, apart from player, it won't have the field X and field Y coordinates. So this is a simple enemy which extends the sprite. And you know, I've been thinking about the structure, and I think it's a good idea if we move class-related stuff into the class itself. So we will refactor the player later, but the enemy is going to work this way. To our enemy constructor, we are going to pass the resources, and from those resources, we are going to actually set the picture that is going to be displayed. So set res enemy. Okay, this will initialize the enemy sprite, but we'll need to draw it, right? And as we agreed before, the enemy is drawn on the right side of the field. Wait, is it mirrored? I think it's, yes, the right side of the field. Make it here on this part of the screen, and yeah, it's in the middle of the second half of the screen. So to do that, we're going to use the size evaluator, which we are going to pass to our draw function. Public void draw. We will pass the sprite batch, which is going to be used for drawing. Call it batch. And we are going to pass our size evaluator, which is going to be used to get the enemy coordinates. And first things first, we set position of our enemy to size evaluator get enemy x while we pass, and size evaluator get enemy y. So obviously we don't have those functions yet. Let's introduce them. Right at the bottom of the file, I'm going there, public float get enemy x function. And you know what? To center the enemy perfectly on the right side of the screen, let us pass the sprite enemy. And you know, it will return. We need to return the coordinates to the right. So we are going to use our measured stage get width divided by 4, and we get the first half of the screen, right? But we need like the second half, so we add half of the stage. We multiply it by 3 and divide it by 4. That's how we get the 3/4 of the screen, like the rightmost corner of it. And to arrange it perfectly, we need to get the width of our enemy sprite and delete it and divide it by 2. That way I think we'll get the perfect arrangement on the rightmost side of the screen. In case of y coordinate, get enemy y, same parameter, we're passing the enemy sprite, but we don't need to care about those measures of 3/4. We just need to take the half of our height and subtract half of the enemy height, and that way we'll center the enemy at the screen. So measured stage get height divided by 2 minus enemy get height divided by 2. If it seems unclear, you can always experiment with those values, and I'm actually asking you to experiment because this way you'll get some clarity. If it's easier, replace the values, like variable values, with the actual constant values. Imagine if your screen is 100 pixels wide and your enemy is 16 pixels wide, and try to actually playing with those values by replacing them. That way you'll get more clarity of what's going on. So get back to our enemy class, and in our get enemy x function, let us actually pass this. As you remember, this is a sprite, so it has those width and height methods already defined. We're just extending it a bit. And but apart from setting the position, we can also call the super draw method. This is the sprite's draw method, which will take care of the drawing by itself. We just pass our badge. So apart from that, I think it's a good idea if we make our player similar to that, because before that we relied on the external game screens assignments, which is not a good idea. So player will take resources too, and it's going to set the player sprite according to resources. So resources player. The player is also going to have the draw function, which will work approximately the same way as the enemy's draw function. Draw. We're passing the sprite batch, and we're also passing the size evaluator. So that way we'll make sure that we're drawing the player always in the actual position. So set position, size evaluator, get base screenings. Because player stands on the base and we know the base coordinates, we're actually getting the base coordinates, and we're going to use it. Get base y, base screen y, field y, and you'll see how it works. After that, we just call the sprites draw function. Same thing. And when we done that, after we did this, let's go to our game screen and actually remove all the obscure parts, like refresh player. We don't need refresh player function anymore. Forget refreshing player, who needs it? Remove the refresh player function and the calls to it accordingly. But and we also need to remove our previous set function, which set the sprite to our player. Now we're handling it internally, so it's a very good idea. And we actually need to draw. Careful with this one, because the compiler won't tell you that you have a mistake, because the sprite itself has the draw function, but we need to call our player's draw function actually. So we pass the sprite batch and size evaluator to our player. After that, I think it's a good idea if we refactor the logic a bit, because the logic needs to initialize player and the enemy, and it needs to pass the resources to them, but it can't because logic does not have the access to resources. So I think it's a good idea if we actually save the pointer to our whole game into the logic. We don't know what might happen later, so let's make a separate parameter, game, which we pass to our logic and declare our game actually inside of the logic. Make the assignment, and after that we can use our game's resources to pass to our player. I think this should work now. I think so. I hope so. Let me launch the game and see what we have. It's compiling. The usual excuse. Okay, and we also need to change the initializer of our game logic inside the game screen. So pass him the game. We already have it defined here. No big deal. So we're passing it. There's our effect, and everything works as previously. It's fine. We have not broken anything. Let's try resizing the window and see that everything is working even without the refresh player function. And it's great. And now the only thing we have to do is to initialize our player in our game logic the same way. The same way we declare the enemy. Alt Enter to import the enemy. It's the only choice, so the Android Studio will do everything perfectly. And initialize the enemy, right after player. Enemy equals new enemy. We pass him the resources only because enemy does not have the same coordinates as our player. Okay, and don't forget to make the enemy constructor public, of course. We have the enemy, and we need to get the getter of our enemy the same way that we have the getter for our player. So public enemy, cool band, get enemy, and we return the enemy the same way. Great, and after that we can actually draw the enemy in our game screen. So in our game screen, use the same approach. So we would not. No, actually, it's not a good idea. In our game screen, inside our draw function, let us call logic get enemy draw. Pass the batch and size evaluator. We're not using the same variable as player. Like, we could make something to mimic this structure here in game screen. When we declare the player, then we logic get player. But I think at one point of the game, our logic is going to swap the enemies. So instead of doing this assignment, let's just make sure, let's just keep safe, and inside our render function actually just go logic get enemy and draw function. I think it's a good idea. So after that, launch our game, see what it is. See, we have the enemy now. We can resize it. The enemy is perfectly aligned on the right side of the screen. And I think it's working great, like we intended. This makes a lesson today. Don't worry, I still remember that we made the effect that is still being shown on the leftmost corner of the field. But, yeah, see? We're definitely going to use it in our next lesson when we'll teach our enemy how to attack. So that's it for today. Thank you for watching, and I'll see you guys in the next lesson. Vladimir is out. Bye.